8 injection molds in 12 days. Welcome to another episode. I was contacted by a viewer at the beginning of December asking me if I'd be interested in making some molds for him, and I said sure, I'd take a look. He sent me the files and they looked pretty challenging, and I was thinking, okay, we can do them a few at a time. So I gave him some feedback on the molds and some suggestions. And then he said, well, no, actually, I want to make all of these molds and I want them to be done so that I receive them by December 15th. And I think this was around December 4th. Now, to give you some context, I have a day job. I work in the software industry. So this is a hobby. It's a part-time thing for me. And so I thought about this for a while and thinking, can I really do this? And I thought, yeah, I think I can. Now, did I also wonder whether or not I was crazy? Yes, absolutely. At retrospect, was I crazy? Probably. So let me take you to the computer and show you the first thing I did, which is to basically look at each of the parts to do an analysis on things like machinability, draft angles, etc., and to provide feedback to the viewer to let him know the things that he needed to change and the things that would be problematic. The first thing I typically like to do is to do a draft analysis. And for that, I'll set this to be the body, and then the pull direction, I'll use this. Oops, let's try this again, body, and then the pull direction. And the outsides, of course, don't matter, but you can see that there is not enough draft here, according to 2 degrees of draft, and there's not enough draft there. So I created pictures of these, and then you'll see what I did with them in a second. The other thing that I wanted to do is to take a look at how deep I had to go. So if we look here and go down to this point right here, you can see, oops, oh yeah, one of the things that's interesting is that he used Onshape to create these, and when he exported them, they all came out in meters. I'm going to switch to inches because that's what all my tools are in. And so if I look at the vertical height here, it's about 1/2 inch. That means I need a pretty long cutter to be able to cut these fillets. Now, if we look at the radius of the fillet, you can see that that's 0.01 inch. So that means 20 thousandths of an inch in diameter would be the size of the cutter that I need to get down there. A 20 thousandths inch diameter cutter that can reach down 1/2 inch would be pretty expensive probably and really, really fragile. So that's one area that I identified right away where we needed to make some changes to increase the fillets. I took a screenshot of the information about the draft angle and then pasted it into a set of PowerPoint slides with a different slide for each part. I skipped some parts because they were okay. Oh, and one of the things that I forgot to mention is he designed the mold mostly. He basically designed the core and the cavity, or the A part and the B part. He did not design things like the runners and the gates and that sort of thing. I added those later. But I provided information about the minimum radius that I thought was viable using mostly a 1/16 inch diameter long reach ball nose end mill. In some cases I had the reach to be able to use a long reach 1/32 inch cutter, and that's what most of these are. They're mostly about draft and about minimum radius. There is one case though where he had some very tall thin structures that, as you can see, were 0.65 inches tall. So that was even taller than the 1/2 inch long reach 1/16 inch end mill that I had. Eventually I ended up ordering some 0.08 inch diameter end mills that were long enough to be able to do these parts. Once I had this PowerPoint set of slides done, I exported them as a PDF and then sent that to him, and then we had a discussion about this. During the discussion, one of the things that happened is he basically said, for some of these things, I don't remember which ones, no, I can't change those, they have to be 1/64 inch even though they're fairly deep. And the end result of all of these discussions is that I decided to try to use a super long reach 1/32 inch ball end mill. I'm not sure that was the best choice because it was really fragile and it worked for a while, and then I broke both of them in fairly quick succession. This is the end mill I'm about to put in to a holder. It's a 1/32 inch diameter ball end mill. It may not be easy to see the ball on the end. This is a super long reach. It's 15 millimeters long. I think it's kind of amusing that they measure the diameter in imperial and the length in metric, but that's the way it is. I need this to be able to clean up the radiuses at the bottom of a fairly deep cavity in the mold, and I couldn't get in there with any other tool. So I'll run this at 30,000 RPM and take very light cuts. I'm going to take this out carefully and then put it in here. And then carefully make sure I don't break it. Okay. Now I'll put it in the machine and measure the tool height. I'm going to start by changing to tool 16, which is the slot that I'm going to put it into. Which is empty. So I'll carefully put it in here. Press tool release. Okay, now we need to set the tool length. I'm going to put the tool setter here, so I want to make sure that this is nice and clean. I'm trying to center it on the pad. That's pretty close there. So now I'm going to bring it down slowly. And then switch to 1/10,000th of an inch at a time. And that's good. So I'll do 2 off for measure. Okay, so now I'll go up in Z, and it's all set. And now, before I do something stupid like bump it, I'm going to put it away. Okay, and then I'll update my chart with the end mill that I just put in. This half the mold gave me a little bit of a challenge. It was about a 5-hour or 6-hour milling time, I don't remember exactly. And if you'll notice here, there are some scallops taken out of the part that shouldn't be there. And these are pretty deep. And I was trying to figure out what caused this. It took me a while to figure it out. But there's a hint here. Let me try to get you a little bit closer. Let's see if this works. So you can probably see a pattern here, which is kind of like arcs that go this way, leading toward down there. This is the culprit here. It's a 1/16 inch long reach ball end mill, and it's not sticking out far enough. It's sticking out less than 0.6 inches, and I needed it, I think, closer to 0.7 inches to work correctly. So I just need to take this out and pull it out a little bit and then reset the tool height. I've paused the simulation, and you can see, if I scroll a little bit, that the nut is hitting over here. I don't have the nut modeled exactly, so the actual collision isn't correct, or I should say it does not match what I actually saw. However, it is hitting, and if I start the simulation, it's actually running pretty slowly. But you can see the issue is that it's just too close. Now, the step down was fairly small, And because of the small step down, it was able to mill away this material without causing a crash as far as my CNC machine was concerned. And again, because of the small step down, it actually produced a fairly nice surface finish on this, but that certainly wasn't the intent. What I learned from this is that I really need to make sure I measure the actual stick out of each tool. And then in Fusion, I make the model stick out slightly less than the actual stick out. What that will do is that it'll ensure that when I'm doing the CAM simulations, I get a collision in CAM telling me that there's an issue, rather than scrapping apart after many hours of milling. Here's another mold half that I ended up scrapping. Fortunately, I didn't waste a lot of time because it didn't take that long to mill this. The problem is right here. This area here was milled with the wrong end mill. And I initially noticed something was wrong because I could feel a lip on here. But then I noticed that the walls were not straight up and down, or with a little bit of draft, which is what I was expecting. They actually have quite a bit of draft. And when I looked at this a lot closer, I realized what was going on. Well, I should say when I looked at the CAM as well, I realized that I was using a tool number in the CAM that was not the same as the tool number that was in the machine. So the tool number that was in the, or the tool that was in the machine for that tool number, instead of being a flat bottom end mill, was my engraving cutter that has, I think, like a 60-degree angle on it. And because of that, you can see that I've got quite a bit of draft in here, and this hole is larger than it was supposed to be, etc. Because the step down was fairly small, it meant that it actually did a fairly good job milling it. You know, the surface finish isn't that bad. It's actually pretty good. But it's definitely the wrong cutter. What I'm going to do to try to avoid this type of issue in the future is to start to use setup sheets and to look at the setup sheet, look at each of the end mills that I have in the setup sheet, and then compare them to the magnetic chart that I have on my machine before I run an operation or run a part. And that should ensure that at least I don't use the wrong tool number. Here's another mold half I ended up scrapping. Again, it didn't take that long to remake it. But there are a few issues with this one. The main thing is you'll see that the gate doesn't actually go through. It bottoms out and it doesn't connect with the back of the mold. So if we look at the back of the mold, again, you can see it doesn't go all the way through. And there are a couple things that happened here. One is that for some reason I got the wrong Y offset. I think I did something and accidentally changed it when I shouldn't have. So one of the things I've taken to doing is to put a little mark here with, when I'm doing the spot drill for these holes, I also do a spot drill there. And the purpose of that is so when I have two mold halves, I know that I need to align these two spot drill locations on the two halves when I put them together, and then the mold will be aligned correctly. But the other thing is, sometimes what I discovered is that when I flipped the mold over, I would sometimes put it in the wrong way. So one of the things I learned to do is, after milling the first side, basically mark the location where I had the X0, Y0 for the mold, so that when I flipped it over, well, let me back up. So one thing is I would be doing is I would take this out of the machine, and then I would deburr the edges because the edges get kind of sharp. So then when I put the mold back in, I could easily put it in with the wrong orientation, with the wrong corner where I should have the origin. So just putting a little Sharpie mark on here, make sure that I put it in correctly. And of course, this will wipe off really easily once I'm done. One of the challenges of parts like this, which have really small radiuses, is to ensure that I mill this as accurately as possible. So one of the things I've been using in the simulation recently that I really like is the comparison view. I have this currently set to show tolerance of 1/1000th of an inch. So if I go through these step by step and go through a little bit further, you can see that it's still not close enough. I'll do the contour. Oh, it's still calculating. And you can see I have, it's accurate on the bottom, but it's not accurate on the sides. If I then run the first contour, You can see it's accurate in most places, but on this somewhat shallow slope over here, it's not accurate. So I added a final scallop, which I'll show you in just a minute, that makes that more accurate. And so after all the passes, you can see a few places where it's off by about a thousandth. If I make this 1.5 thousandths, then you can see it's pretty much green. So that means that with this strategy, I can be accurate to within 1.5 thousandths, which is enough for this part. So here's the contour strategy, which is picking up the vertical walls pretty well, but not the shallow walls. And so I added a scallop here to pick up the shallow walls. And one of the things that I did with the scallop is I made the passes, the step over, 5 thousandths of an inch. I probably could have used less than that, but this is 6 minutes and I'm not looking for cycle time on the machine. I'm looking for quality of the finished molds, so I'm okay with longer cycle times, so I don't have to do polishing to get out tool marks. So this should be pretty good, and the surface finish should be just fine. One of the problems I've been having is that the mold halves do not close all the way. You can see there's quite a bit of a gap. And it took me a long time to figure out what it is, because of course I can't see into here. I eventually did figure it out, and I'll take you to the computer to show you what the issue was. After staring at the mold for quite a while under a microscope, first a stereo microscope and then a digital microscope, as you can see here, I finally found a little island, a triangular island that was at the end of a flat area that was causing the issue. The area we just looked at on the microscope is right down here, and the cam for that is down here. And if I look at the cam, everything looks fine, and if I look at the quick simulation, everything looks fine, unless I zoom in, and then you can see there's this tiny triangular piece right there. And that's what the issue was. So for this one, what I ended up doing was to add another operation. Basically, let me turn that on. So another pass that extended it. If we look at this cam operation, you can see I have an additional offset, and the additional offset ensures that we go all the way past the end there and clean up that final piece. And as you can see there, it did clean up that final piece. I could do a full simulation that takes longer, but basically that was the issue. So what I did is I ran this operation again, basically putting the mold back in the machine, and then used the 80 thousandths diameter long reach flat end mill to get down there and remove that piece. Once I did that, the mold halves fit together perfectly. I did not take photographs of all of the individual molds that I made, but here are some photographs to give you an idea of the complexity of the molds. These represents many, many hours of machining over, as I said, about 12 days, but the results turned out pretty well. Here are some photographs that the viewer sent me of parts that he made from the mold, so you can get an idea of how they turned out. And the streaking you're seeing is from water because he did not dry the molds before making these parts. This was quite the project, and I learned a lot and pushed my machining skills to a level that they weren't at before. There are some mistakes I made that I showed you that taught me some good lessons I'll put into application in the future. I'm certainly glad I did this project, but there were some days where I didn't get a full night's sleep. In the end, I delivered most of the molds by the 15th when he wanted them, but there were, I think, 1 or 2 molds that I ended up delivering after the 15th because of various things and running out of time, etc. I also ended up remaking one of the molds, so I actually did 9 molds, not because of something that I did wrong, but because he discovered that he needed to make a part a little bit thicker. So that was fun too, and that wasn't as stressful because it turns out that the mold he needed to have redone was the easiest to make mold, so that's a good thing. So I thank Jack from ModMount for giving me this project. I know he's happy with the results, so that's a good thing. What I'm going to do is, I haven't shown any machining footage yet, but I'm going to put some machining footage in after this little exit, and you can watch them if you like. Please subscribe, give me a thumbs up, comment below, and I'll see you next time.